Let me start the recording here. So we have a situation that has us look at a very unorganized data set and try to interpret it. It says that Roland owns 2 hotels, one in New York and one in Miami. He wants to find out whether there is a difference in the number of nights guests stay at the hotels. He therefore inspects the last 40 reservations placed for each hotel and records the number of nights the guest stayed. So if we look at New York, for example, that first number 2 means what? One guest stayed 2 nights. Okay, another guest stayed 3 nights, etc. So right now, looking at that is unorganized. How can we organize the data? Frequency, right? So some sort of order to that list. So an ordered list, and more specifically, looking at the frequency. Okay, so an ordered list. And we're looking at the frequency. So when we're looking at the frequency, what do we mean by that? Yeah, how many guests stayed 2 nights? How many guests stayed 3 nights, etc.? How can we display that? A dot plot is one way. We'll talk about that. A column graph. Yeah, that's one type of bar graph, right? A column graph. We have frequency tables, right? Which we're going to take a look at today.
Possibly a line chart.
Yeah, possibly a line chart as well. So lots of different ways we can visually display the data that we're looking at. What is the most common length of stay for the hotel in New York? 2 nights, right? 2 in New York. What about in Miami? 3 or 4 nights, right? Okay, how can Roland best measure the average length of stay for each hotel? How do we measure average? Yeah, that's called the mean. We can find the mean. Now, when we're looking at data, are there things we should consider? And I don't know if you know this yet, but based on your research, are there things we should consider about specific data points when calculating the mean? Outliers. What are outliers? Do you remember? Yeah, either extremely small or extremely large values. So they are outside, really, of your pool of data. So,
8 nights.
Yeah, I mean, more or less, I wouldn't say 8's an outlier. I would say something like 15 nights. That is more of an outlier, right? Just because something is your largest value and there's only one of it doesn't necessarily make it an outlier. An outlier is extreme values, okay? So, mean, but you have to account for outliers. So the mean. And what's right now the only way we know how to measure spread? What's that called? Range. What is range? Yeah. So we're going to take a look at things like variance and standard deviation, which are better measures of variance than ranges. But in this case, when you're dealing with a small data set, when you're looking at the spread between the highest and the lowest, range is the best way to measure that spread. Can a reliable conclusion be drawn from the data? What factors could affect the reliability of the conclusion? The location of the hotel, certainly.
If you really say, like, oh, Miami was near a beach, but New York was deep in the city.
Right.
It would affect why more people.
Exactly. So the location, that's definitely one. So let's just write some of those things. So the location. Holidays, right. We just know that he looked into the last 40 reservations. We don't know what time of year he looked into those last 40 reservations, right? What else?
The cost.
Yeah, the cost, certainly. So because we have all of these underlying factors that he hasn't accounted for, can we draw a reliable conclusion from the data? I would say no, right? Plus, it's over 40. It's for 40, not over 40. It's for the last 40 reservations. If he truly wanted to improve the accuracy, the whole what? The whole year, right? What's accuracy? So we have something called accuracy and we have something called precision. Do you know the difference? Okay, so we're going to take a moment. I'm going to have you, if you don't know the difference, look them up. And then in about 2 minutes, be ready to tell me the difference. All right, so what is the difference between accuracy and precision? Someone tell me. Hannah. How close you are to the truth, the actual answer, right? But what if something is precise? What do we mean by that? Yeah, when it's really close together. So if you take an experiment and you repeat that experiment and you get the same result and you repeat it again and you get something close to that result, you may say that that's very precise measurements, but it may not be accurate. It may not be actually what you're looking for in terms of a value, but you have precision, right? So when we say how could Roland improve the accuracy of his investigation, if he increases the time, instead of saying just 40 reservations and looks over it for a year, that would potentially that would give a better indication of his accuracy, right? Because you're taking into account more days, including those holidays. Do we have any questions?
So it's like if you took a dartboard, and like accuracy would be like trying to get
As close to the center, so if that dartboard back there, as close to that target center as possible, you would say, oh, that's a very accurate
but if it
shot.
Was all your darts near each other,
Yeah, precise. And you could be precise and accurate at the same time, right?
and be wrong.
Yes. So statistics, what is statistics? We have 3 different contexts. It says statistics is a branch of math that is concerned with how information is collected, organized, presented, summarized, and analyzed. Your summative is essentially that. You're going to take information, you're going to collect it, you're going to organize that information, you're going to present it, okay? You're going to present it graphically, you're going to look at things like standard deviation, you're going to summarize that information, and then you're going to draw conclusions from it. That is your summative. Statistics are a collection of facts or data about a group or population, and a singular statistic refers to a quantity calculated from a sampled data. So a mean is one type of statistic. A median is another type of statistics. And as you know from your research, you have something called a 5-number summary, right, with your mean, median, mode, etc. Did you know a singular piece of data is called datum? Datum. But because we usually collect more than one piece of data, we call it data. Okay, you've got a datum and data. All right. Now, data can be classified as either categorical or numerical. Okay, so categorical is qualitative. What's the difference between qualitative and quantitative? You were right the first time. Quantitative, like quantity, is numerical. Qualitative is non-numerical. So gender, race, those sorts of things are qualitative, right? They have to do with a specific category. That's why we call it categorical data, and it's non-numerical to be more specific. Numerical data, discontinuous. This is something that people struggle with. students seem to struggle with, which we'll have plenty of practice with.
So,
All right, let's move on. Let's go back. So there are two things that we should understand about our types of data, and that's called disaggregate data and aggregate data. Now, I'm not going to make you accountable for knowing what this means, but big picture-wise, it's a good one to know. When you do your research, in college especially, if you get a master's or a PhD, or even an undergrad, you're going to be dealing with statistical analysis, and specifically you're going to be looking at two types of data, disaggregate data and aggregate data. When I got my master's in teaching, that's one of the things that I did. I looked at disaggregate data and aggregate data. Disaggregate data is your big picture data. So let's just take one example. If we're looking at test scores for disaggregate data, we're looking at all of the schools in a particular district, or maybe all the schools in Shenzhen. That's your big picture data. Whereas aggregate data is saying, let's take one school, like ISNS, right? And let's look at the test scores for ISNS, but then let's break that down even further. Let's look at the test scores for 9G, and let's break that down even further. Let's look at the test scores between boys and girls in class. That's aggregate data. Does that make sense?
let's break it down to the set scores between aggregates.
Yeah, so disaggregate data, you think your big picture. Big picture. Yeah.
How do you spell that word?
DISAGGREGATE. That's your big picture. So for example, data from multiple schools. Your aggregate data is data from individual schools, right? And breaking that down. That's your small picture. And student groups. Questions? It's always great whenever you are writing a research paper in graduate school and you're like, okay, I'm going to look at the disaggregate data, and then somebody reads it and like, oh, they think you're a genius. It means more specific to something. So if you're looking at the disaggregate data, like I said, for a bunch of schools, your aggregate data can often, yes, be more data because you're looking at more specifics. So you're looking at the test scores for a school, the test scores for a class, and the test scores between boys and girls. Aggregate's more specific. Big picture. Yeah, big picture. All right, any questions so far?
So you can only decide which kind of data it is by comparing it.
Yeah, so if you look at the data as a whole and you say this is data about a lot of things, let's say all the restaurants.
Actually, if you have, for example, you have data about the school in Shenzhen and you have data about school around the world, so can we say the Shenzhen one is the second?
Yeah, actually, so Star brings up a good point. Just because something is disaggregate data in one context doesn't mean it's not aggregate data in another. Does that make sense? So what Star said is, okay, let's say we're looking at schools in China versus schools in the world. Well, looking at schools in China, that's more aggregate data when compared to schools of the world, right? So yeah, it doesn't mean just because one's disaggregate, it's going to be that all the time. All right? Excellent. Make sure I'm getting all my notes here. All right, types of data. All right, categorical data. So, make sure I have everything here. Yes. So, categorical data describes a particular quality or characteristic. The data is divided into categories, and the information collected is called categorical data. It represents things such as gender, marital status, hometown, or types of movies. Extension. So if you want above a level 4, something to know is nominal and ordinal, okay? So your non-numerical data can be classified as either ordinal or nominal. Yes, yep, I'll put the key. Okay, so ordinal categorical data has to be ordered. That's why it's called ordinal, or it has more specifically some type of scale, right? So it's ordered, or to be more specific or more clear, it has a scale. So, for example, how are you feeling? Good? Bad? Okay? That has a scale. Tired, right? So you can feel anywhere from, this is the best day of my life, to, oh my gosh, this is terrible, I just want to go home, right? That's non-numerical, but there is a scale to it, right? Something that is extremely good, we can't say that they are of the same level, right? So that has some sort of scale to it. So, for example, how are you feeling?
Very controversial ordinal scale.
Yeah.
Like, I know, like, the pain scale that doctors give, that's kind of controversial.
Yeah, so the pain scale that doctors give, yes, Oscar asked something very interesting and relevant. Sometimes we make ordinal scales that can be debated, right? So more or less, if you go to the doctor, they'll say, how are you feeling? Or how's your pain? They'll say, oh, my pain is awful. You know, they'll have you rate your pain on a scale of 1 to 5. They'll put a numerical value to it, but more specifically, they're looking to assess your pain level. Now, your pain level, you know, it depends on your condition, and that may...
It also depends on the person, because some people have more resistance.
Yeah, some people have more resistance to pain than others. So, yeah, there is some controversy there. Now, so nominal data is something that's non-ordered, or there's no scale to it. And that's things like your race. What's another? Or it doesn't really matter, the scale doesn't matter. Your favorite color? Right? Your favorite pet?
Best Star Wars movie.
So pets, colors, those sorts of things.
Wait, gender would count too.
Mm-hmm. Yep. Questions? Yes.
What is more numerical? Is it ordinal? Is ordinal more numerical?
No. So Lily asked another important point. This is specifically non-numerical data. As soon as we go to numerical data, we're leaving the world of categorical data and going to numerical data, which can be classified in 2 different ways as well. All right? So, before we get to that, the occupation of workers at a hospital is a categorical variable. For example, are you a doctor, nurse, a secretary, a cleaner? You can organize that data through pie charts, bar charts, column graphs, things like that. Now, to Lily's point, we have numerical data, which is information that is collected in numbered form. So what's an example of numerical data? What? Say it.
Data was numbers.
Well, be specific, like to a real life example.
Like how many students choose which club?
Yeah, how many students choose which club, your test scores, right? That's all numerical data. So, how many students choose a club? Your test scores. What else? What other example of data has numbers that we work with specifically? How many students are in each particular grade, right? So when we're talking about numbers, we're talking about numerical data. Now, there are two types of numerical data, just as there are two types of categorical data, and that is discrete and continuous. And students, they get the concept, but then when they're given a ton of different examples, they sort of get confused between the two. So this is really important because these words you're going to see often as you progress in mathematics. So let's learn about what those mean. Discrete data is counted, but the most important thing you need to know about discrete data is that it can only take integer values. What does that mean?
How many dots?
Well, specifically, it's only those natural numbers, right? They say integer values, but we really can't have negative numbers, right? So they say the number of students in a class. Well, we can't have half a student. So that is discrete data. Anytime you look at a situation, a particular scenario, you have to ask yourself, is the data that I'm dealing with, is that data something that can only take on those natural number values, 1 or 2 or 3 or 4, or can you split it? So for example, tickets, the number of ticket sales. You wouldn't sell half a ticket. I mean, would someone buy it? Sure. But you can't sell half a ticket. You wouldn't want to sell half a ticket, so that is discrete. Does that make sense? Yeah, your height is continuous data because your height can take on those non-integer values, and your weight can take on those non-integer values. Does that make sense?
Yeah.
Questions?
Yeah.
No? Okay. So, as Hannah said, it can take on any value within a range, your height, your weight, not just certain fixed heights, time in a race, a dog's weight, the length of a leaf, that's all continuous. You will have to classify your data as discrete or continuous. Here's a good chart that I wanted to insert that shows the two types of data, your continuous data and your discrete data. I'll put this on your key for your notes. Oh, it's on OneNote. There you go. So you've got your ordinal and your nominal with some examples. Nominal, alive or dead. You can't be somewhere in between. And then continuous. Things like blood pressure, height, and weight. And discrete number of children. Can't have half a kid. All right. Okay, some things that you did research on, tally and frequency tables and column graphs and dot plots. We're going to take a day to really work with data and make frequency tables, column graphs, dot plots, stem and leaf plots, those sorts of things. If you look here, here's an example. Here are 3 examples that you could take from that hotel and you can put into a table, a column graph, or a dot plot. Each of these measures frequency in one way or the other. So here, you've got 2 people stayed for 3 nights, 9 people stayed for 4 nights, etc. You have that column graph, and you have that dot plot. Dot plot actually is used often in sports statistics, and I'll give you an example of a specific sports scenario that uses dot plots. Like things like basketball and things like that, when you're looking at specific stats in basketball, oftentimes the easiest way to organize the data is with a dot plot, and the most common way is with a dot plot. So those of you that are interested in sports, your final project could be something over basketball statistics or, whatever you're interested in. Have you all constructed stem and leaf plots before? Basically, your stem and leaf plots is just taking your data and cutting it down between your ones place and your tens place, okay? So let's take a look at an example here. So this means 17, 11, 28, 23, 26, 27, right? This allows you to group things in a more orderly fashion because it tells you, okay, the numbers for your tens place, your 20s, 30s, 40s, and 50s, right? And you always have to include a scale. That's really important. All of your graphs have to have some sort of scale or label so that we know how to read it. So your stem and leaf plot will tell you this. 5 R1 means 51, okay? An order stem and leaf plot just puts those things in numerical order from least to greatest. Questions? Good. We're done.